This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seeberg and I'm your host. And today I'm going to be talking to Ram Seetharaman. He's the head of AI. He's a product manager at Synera. And Ram and I are going to be talking about AI agents in engineering. And we're going to focus in on actually building your first digital engineer. Hi, Ram.
Hi, Peter. Thanks so much for the invitation. My pleasure to be on this nice round of podcast series.
Thank you. Very much looking forward to one of my favorite topics, all around agents. Okay, why don't we start with you introducing yourself to our listeners, please, Ram?
Sure. Thanks, Peter. So I originally come from India. I did my bachelor's in mechanical engineering from the south of India. And mechanical engineering was always running in my family because my father was in the forging industry. So I was spent some of my childhood days on shop floors looking at aluminum castings and forgings. And therefore, naturally, I was drawn to mechanical engineering. During my bachelor's, I always wanted to be part of simulation because it was really fascinating how everything could be simulated inside a screen. So that's why I came to Germany, where the best cars are made and the parts get made. So I joined the University of Stuttgart to study computational mechanics. So right from 2019, I started working on AI. So that time it was more machine learning and deep learning. Ever since then, and then with a lot of opportunities at the University of Stuttgart, I jumped into physics-informed neural networks, physics-informed deep operator networks, which is not so popular, and then slowly moved into NLP and LLMs for the last 2 years. I also have a very hands-on experience in building cars. I also worked at Volocopter for 1.5 years. So very much in love with mechanical engineering. And now I have the great opportunity to build agents for engineering in Synera and work with a lot of our customers from this domain. So that's all about me.
Perfect. Thank you very much. Yeah, you were born in India. I wasn't aware of that. I mean, some of our listeners may be aware that Robert and I have been running a number of podcasts with folks directly from India, being in India. So that's not part of that, but that's perfectly okay as it is, right? We did talk about chai already in the beginning. I had a little bit of a technical problem. We started a little bit late and we talked about chai. And you mentioned the University of Stuttgart. Now, I saw in your profile that you have been part of the team that won the Siemens Digital Twin first place that was in the World Champion season 21-22. You want to quickly talk about that one?
Yeah, sure. This particular thing was really interesting because a Formula student is like a student competition that is worldwide. So there are thousands of students from all around the world visiting the Hockenheim Ring every year for the Formula Student Germany. And in this event, Siemens runs something called the Digital Twin Award. So the goal is to find out teams that excel in using digital tools for building their cars. Luckily, we have also, when I was working at Green Team, now it's called Ren Team, Siemens was a sponsor to us, or they basically sponsor every team with the tools. And we had the opportunity to basically dive into all the tools. And I was leading a small group of my friends and fellow teammates into exploring what it could mean to create digital twins of our Formula car while it runs. So I used to work with Mendix. We used a lot of AME Sim to figure out how these two worlds fit together and created our own apps. And this was a highlight. Also, when the car was running, we were able to track a lot of real-time analytics to try to keep up with how the driver is driving the vehicle and adjust our plans. So, yeah, it was a really great experience and always thankful to Siemens for giving that great opportunity and the award with the huge cash award.
There you go. A nice thank you to our partner Siemens. And by the way, I saw Mendix yesterday was chosen by Gartner again in the the right top of their magic quadrant, but that just happens to come in, as you mentioned him. And the Hockenheim Ring, for those listeners that do not know, is a racetrack.
Correct.
Right. Yeah, right. Just for people who haven't heard about Hockenheim. There you go. Perfect. Tell us more about Synera as a company. What does the company stand for? We're going to be later go into all about AI and engineering. What does the company Synera do?
Absolutely. And before I go into what Synera do, maybe also an interesting story, at least for me, is also when I was in this Formula student, I used to use Synera. And this was also part of the award when we won it with Siemens. So that is how I came to Synera. So we worked together to create a tool ecosystem connecting Synera and Siemens, which Synera already had. And I was really fascinated with what Synera can do. And Synera is basically a process automation platform. And this means we as engineers typically have parts and processes. Synera is more focused on capturing these processes that happen in engineering, for example, CAD, CAE, also a lot of pre processing and post processing tasks, and digitalize them into workflows. And these workflows can then be consumed by a lot of engineers within an organization. And some of our typical customers are large OEMs like NASA, BMW, all around the world. And we also have a lot of suppliers who use us for a typical use case called the request for quote. So this is a very business critical process. And what we try to do is help these customers and companies accelerate their development cycles or accelerate their processes. And for the last 1.5 years, since we are an automation first platform, agents were kind of inevitable. And we had the opportunity to work with a lot of pioneering companies to develop the Synera multi-agent system that is a product offering inside Synera today. So that's Synera.
Very good. Now, why would potential customers be interested in the solutions? You talked about the workflows, or from a different perspective, what are typically today the challenges for engineering teams, and for those reasons they might then be interested in the solutions provided by Synera?
Absolutely. One of the challenges that we always see is how many repetitive tasks an engineer has. For sure, there are a lot of advanced surrogate models, there are a lot of state of the art simulation solvers, and a lot of improvements happening. But somehow, there are some tasks that are really repetitive, not just at an engineer's desk, but maybe at a team meeting or throughout the organization. There are many tasks that can be simply automated. And one of the important value propositions that Synera has is we help them identify such tasks where there could be simply an automation saving time by doing all these tasks. And this means that it could be a simple Excel automation, but also, like I mentioned, a complete part development cycle that can be automated. A very business critical thing like the request for code process. So we help our customers identify these automation opportunities and try to guide them into an automation mindset. And usually, this is more like a transformation. And our customers are most valuable when at the end of the day they realize, yes, this automation worked and I did save my time. And I can also suggest this automation for a lot of my colleagues who also face the same challenge of automating things by themselves.
Right, that's understood. In general, maybe you want to go one step deeper and share 1, 2 use cases, what a typical manufacturing engineer can do, what a cost engineer can do, maybe even what sales within a company can do in cooperating with the engineers.
Absolutely. That's a very interesting question because by automating engineering, we realize that not only engineers feel benefited, but it's actually other business teams that get benefited. So, an example is this request for code process. So, typically, what happens is an OEM writes an requirement and they need to send it to a supplier. And once the supplier gets this, package or a document, they need to go through all of these things, understand technically what is written in these documents, and then they need to derive what we call like technical specifications, and then the actual engineering process begins. And even in this engineering process, there are a couple of standard processes. So first, we need to have a review with a bunch of engineers to see, do we already have something like this from the past? Do we already know what is the right solution? Or is this a completely new innovation that we need to think about? Most of the cases, it typically comes somewhere close to an existing part because that is what lands in a department. And if it's an existing part, then engineers usually take this part, they kind of adapt this to the new requirements. Then they need to run a lot of simulation verification, analysis, do a physical test bench, and then they need to cost it, and then they need to respond back to the OEM. And this is not a one process. This is not a, let's say, once done process. This is the exact process that happens multiple times across the year, across product groups, across divisions. And when one department or one division starts by identifying that this is the process that we do, the requirements come in, our engineers or mechanical engineers then need to collaborate with the purchasing, with the costing. Once we capture this information, and then we also connect all the simulation tools, this, at the end of the day, the agents use these tools, talk to each other, and automate tasks at a higher order of magnitude than what it takes for humans. So that is a typical, let's say, what we do with the agents and Synera.
Very good. Talking, you introduced your product groups, and I discussed it with Robert, I think a week or two ago, initiated by Andrew Weng a couple of months back, I believe, the relationship between what he mentioned as an example, PMs, product managers, and engineers in general. Maybe we talk about it at the end again after we have talked about, because you're going to even further increase the speed at which engineers can work, right? And what does that then mean for these other product groups that are typically, where are they? Not in front. More of them are behind the engineering, I believe, right? So they will, I think that's what you're suggesting already. So each of these product groups will need to speed up their work as well, right? So, but these relationships are changing depending on what product groups are taking the initiative to go faster, or
Exactly. I think maybe a good example would be something like a brake system. A brake assembly actually consists of multiple products. And if all of these components are not, you know, produced at the same speed, the bottleneck still remains on the weakest member of this assembly. So you're absolutely right. What we usually do is start with one, but then because of the nature that Synera is, because these are workflows, you can just copy paste them. Of course, you adapt them a bit, and then you can also copy paste the agent. So the repeatability is really faster. But you're absolutely right. We need to do this for all the involved components, let's say.
yeah, maybe we come back to this at the very end after we've listened to what it is that you're going to be doing with AI within engineering. And before we get there, I'm not sure that you already looked at another wonderful video introduction by OpenAI, 1.5 hours introduction of GPT-5. That was last night for me over the US daytime, I believe. I wasn't planning for this, but the question nevertheless is exactly the same. So could I, as an engineer, be using a coding agent like Copilot, or as you may have seen, or like our listeners in the meantime may have seen, also GPT-5 was presenting, can I use it as such for my engineering task? Or would you say, no, engineering is structurally different?
Yeah, that's a good question. And I think, yeah, I also watched this GPT-5 introduction yesterday. I think that was 7 p.m. in the European time. Was really fascinating with a lot of updates. And I think they have a mixture of experts where the models can choose what is the right model for the answering. So I think it was amazing updates. I think by today or tomorrow, we should also be able to see a lot of benchmarks comparing GPT-5, the GPT open source, and all the previous models. So I'm also curious what this means. But now coming to your question on engineering, the way we see this at Synera is basically there are two components when we talk about engineering. So one is the ability to evaluate designs or evaluate ideas. and the second one is how do we do them. And today, if I talk to an engineer, or let's say I talk to a junior engineer and I talk to an expert engineer, and I show them probably a brake caliper from a Formula car, a junior engineer would have first thoughts about them, and they would need to validate what they think could be evaluation. And the expert engineer can for sure take a very educated and very close to correct answer, but they still need to use tools. And what we see with the models evolving from GPT 3.5 to now GPT-5 or any family of models is that intuition is definitely increasing. The intuition for these models to evaluate things is increasing, but when it comes to structural engineering, we always need to be sure. We always need to know what is the exact maximum stress, what is the factor of safety. And this cannot, let's say, this we need some kind of tool for the models to do this, because they cannot run a million mesh size matrix multiplication all by themselves. And that is where I see it a bit different. Of course, these models are capable of coding, but what they do in the behind is they were trained on millions and billions of tokens of codes. But for engineering, this is a bit different. There are also some models that focus on designs, but what we see at Synera is that no matter what models evolve, they always need an entry point into using tools. And for engineering, this is where Synera comes in. We provide very easy interface for these agents to access engineering tools. And these tools can be, or these software that we want to connect can be from any decade of engineering. It could be a 1980 product, it could be a 2000 released product, but we need that ecosystem to connect tools to agents or to these LLMs, and that is by nature different from a lot of other advancements in the coding world. And this is how we see it, and this is also how our customers see it.
Right, and may very well stay that way, although at the same time, of course, many, but that's not the suggestion I'm making here at all. It could very well be that even in 10, 20 years, who knows, you can't even look 10 or 20 hours into the future these days. That is exactly going to be the case, that you're going to have very specific models. There's going to be one for engineering, one for language, one for coding, one for doctors using, one for whatever. Or that's one view, and the other view is there's going to be one. Now, there's only going to be one. Nobody really wants that already from I believe from a human feel and perspective. But that was actually not the reason. That's not where I was coming from there. So, okay, you very clearly explained the different environment, the specific environment that we have within engineering. Now, then let's move into today's topic, AI agents in engineering. We've discussed, and you have listened to yourself, and many listeners have as well, I believe, in the last probably couple of months, now half a year maybe, agents. From your perspective, let's start exactly there. What is, from your perspective, an agent?
Absolutely. Yeah. I think what we learned was everyone seems to have a different definition, but we thought to go with what the word itself means. And agent means agency, and agency means the ability to act on oneself. What this means is, let's try to compare it with an automation. An automation always needs inputs that needs to come from a trigger point. This trigger point can be a human setting some inputs, it can be an email or any event happening that triggers an automation. What agents can do, or the way agents differ, is when we give them or equip them with tools, the agents can decide when to use what tools. And this is agency and this is agents. I think the word agent is itself not very new to the software world. Previously, there were software agents, exactly. But when the LLM boom happened, or let's say what's happening right now, this got democratized even more. So what we see now is or what seems to be the definition of an agent is an LLM that has a tool, and the agent can decide when to use what or when to perform what action with the tools supplied to it. So I think that is a very, let's say, agreed agent definition as of now. There are also right now in the communities a lot of, let's say, discussions about when is an agent automation, when is an agent really autonomous agent, and when is an agent assistant. So I think it will need some time until everything settles and we get clear definitions. But in Synera, when we mean an agent, for us it means an agent or an LLM that has some, let's say, orchestration on top along with engineering tools. And this is a Synera agent, what we do.
Very good. Yeah. And, autonomy is the same topic, kind of, I've talked about many times. None of these systems should be autonomous, full autonomous. I mean, other people say, what does it mean? What I mean is that in the end, there's always going to need to be a human to push a button, and when you push a button and you say, okay, now I put you system into an autonomous mode, then you can say, okay, now the system can be completely autonomous. But whenever we do that, I believe, and those systems may be systems that then from that point on will be working for days, for weeks, for months, until whatever happens, and that could happen within 1 minute. There's going to be, a safety barrier that makes it come out of its autonomy again and given back to the human. But that's a different discussion. Very important. I heard you call the LLM in one of your trainings, the brain. I would agree. It's when we talk about AI agents, that is what the LLM does. So I think the LLM, the language model, gives a human more, let's say, human interface to the agent, right? So having said that, I would say, how important for that reason then is it to choose the right large language model, and does your today's customer or future customer have an option to choose between different LLMs, and how should they go about doing that?
Absolutely. I think the way I understand the question is, how do we know for which engineering task which model to use? That's typically how I also see it. So I think engineering has a lot of, let's say, sub intricacies. So writing a report is also an engineering task. Writing a well detailed report with description. What is also engineering is designing the next generation of sports cars with the new styling concepts, with new class surfaces. So this is also engineering. And the way we look at it is the LLMs from these big model providers like OpenAI, Meta, and so on, these are going to kind of pull everything along with them. So we need to constantly understand how much do these models perform on engineering tasks. And that's what we do inside Synera. We try to take standard engineering tasks and we kind of work on an internal benchmark to see how much do these models have differed or are differing in terms of interpreting the outputs of engineering tools. So let's say I have a suspension bracket. Can I give this as an image to a multimodal model? How do these models interpret it in a different way? And then we go layer by layer. We then give an FEA result. Of course, we explain what load step has happened. And then we try to see across models which can interpret the results in what way. So what we first, when we talk about LLMs for engineering, we need to kind of figure out what task do we really mean. Is this understanding a technical report? Because for that, we really don't need a multimodal model or a VLM or a visual language model or a vision language model. We probably take a large language model that has multimodal capabilities and we try to see how it can perform. So what the best way to do this is, if we want to automate a process, we look at what are the different tasks that are going to be done, what are the different agents going to do, and supply each of the agent also with a different LLM. So one model, one multi-agent system, and that's also the beauty of multi-agent system, that we can have multiple LLMs that are now agents and can come to a conclusion with their differing intelligence capabilities. So a reporting agent could still be GPT-4, but kind of the supervisor agent could be tomorrow GPT-5. And this agent now leads the coordination, the planning, the decision making, and so on. And the other agents could focus on engineering tasks like writing reports, calling the tools, interpreting the FEA results, and so on. And that's, I think, the currently how we do it at our customers. So we never came to, as of today, we never saw a system that where only one LLM with one tool or with one agent can automate the reality of engineering processes. We always need to break it down. We always need to give the agents the right context. So we need to do a lot of context engineering, and then the agents can act better in a modular fashion. So this is typically what we do. We lay out the process as it is in reality today. We map out what is the complexity of each task involved in this project, and then we pick the right models for each task.
Right. And the world of models is changing daily, as we, again, not only just experienced within the last 24 hours. There was just one that we refer to, but there's many other ones. And one additional question, one of the decision points will also probably be what preferred LLM is the customer using, plus related to, is that then running in the cloud or is it running locally, I assume?
Yeah, I can only agree to this. What we realized is depending on the size of the company and the industry it operates in, there are different regulations. And for us on a personal PC, we can, of course, get any API key and just try out things. But this is not the case when engineers want to actually use it. So, what we do in Synera is we work with the hyperscalers like Azure or Amazon, or we generally prefer that the customers kind of point us to their hyperscalers. And then we use the models that are approved by the IT and the AI team of that organization. So it takes a bit of a time until this team will approve the models, but I think things are moving fast nowadays.
Yeah, sure. Any other way doesn't really make sense if you're going to suggest something that the responsible people in the company don't approve. So then, why don't you take us by the hand, by the ear, so to say, and maybe going one step in my brain, you've talked about what Synera does, providing workflows for engineering. And now I understand what you do is kind of making the next transitional phase of a workflow to become an agent. Can I put it like that?
Yeah, exactly. Equip the LLMs with these workflows. True.
Okay, then just give us maybe one or two examples, building, you refer to an RFQ, FE analysis, whatever it is that you feel, and tell us, because I've been looking at your webinar and here repeated by words. What is the 1, 2, 3 steps that is going to be different for an engineer listening, which maybe until today has been using your workflows? And what is it that you are suggesting for the near future or from today on that he or she is going to be doing?
Absolutely. I think it's going to be more of an oratory of what usually happens. So let's see how it goes. So, what we do is, let's say I'm an engineer, I'm working in a group of 7 to 8 engineers, and we are focused on working on suspension brackets. What we need to do is when we Synera, we try to automate, or let's say try to identify opportunities for automation. So what we typically do is go to this group of engineers and ask them, how do you work every day? What is your day-to-day job look like? And when do you talk to another engineer? So once we ask these questions, we actually get the prompt that needs to go into the agents later. So we actually talk to the engineers, we try to understand what they do, and then we collect these roles for the agents later. Now, once that is done, we also ask these engineers, what are your everyday tools that you use and how do you use them? So one engineers could probably using Excel for 90% of their time, and then
Still right.
exactly,
Still the world's most important data repository, still Excel. Amazing, isn't it? Okay.
exactly, yeah. That's exactly. And we try to understand what do they do exactly with Excel? Are they searching? Are they looking up? Do they use any other Excel databases to look up something? And then we build this into a workflow. So when I mean we, actually this engineer themselves can build these workflows because they know best what they do. So this user has Synera installed on their desktop along with other tools, and they can connect, for example, Excel to Synera, and then basically build a workflow of what they typically do every day into a workflow. And we do this for every engineer. We go to a CAD engineer, and then we see that this person usually begins with a parametric CAD model. They adjust few things. They need to verify some CAD checks for manufacturability. Again, we ask this engineer to use Synera and build what they do every day into workflows. So typically, it goes for every engineer, and once all the workflows are available, then we have the prompts already collected, and now we go into the agent creation step. And what we do is this is where we also support. So we say, okay, this is a CAD task, so probably you need to use this LLM, and there are like 5 agents now. We need one supervisor to coordinate everything between this agent. So let's go for a more suitable LLM for this. And of course, this is all approved by this organization's IT and AI teams, so it's safe. And then these creators or these engineers who build the workflows can also build their agents. So they prompt whatever we collected as prompts, they input into the agents, they plug in their tools, and every agent gets connected. And usually a supervisor is also created, like who will talk to the human, can send feedback to this group of agents, and then we build this multi-agent system. And once this is done, we need to consume this. We need to use it to see if it works in the sense it was designed for. And then we publish this agent again within their IT environment. So this is not on cloud, this is not on our servers, this is within the IT environment of our this customer. And then they talk to this multi-agent system. They can also input their CAD files, text files, FEM decks, whatever they want, because we prepare the tools for it. And now this multi-agent system can figure out what is the request that I'm getting. Am I getting a task to just do some data analysis? Then I will just use my data agent. Am I getting a task to do simulation? Then I need to go from data analysis, CAD, and then simulation. So these multi-agents, they have the, let's say, choice to decide when to call which agent in which order and use the tools and respond back to the human user. So this is a typical journey, what usually takes a couple of weeks to achieve, that now I summarize in a few minutes.
So is it fair to say, as I believe I suggested before, just because that's the way it works in my brain, is that you're transforming from workflows to agents?
Absolutely. What these workflows contain is the day-to-day processes. And instead of writing huge pages of prompts, these workflows are just a visual description of these. That the processes get documented, so it gets plugged into an agent.
Now, what does that mean? I mean, we know the general story of, how does it work? If you have a hammer, every problem you see is like,
Yeah.
don't know how you put it, but you feel where I'm going
Absolutely.
to. So, does that mean that at some point in time, let's say maybe not next week, but maybe next month or a year from now, your customers will not be using workflows anymore? Or would you say, no, it's probably likely that for a specific number, which can be small or big, people who want engineers that want to and are very happy with it, they're going to be just completely working with agents, other ones there? Or is there still a use, let's say, for the workflow level? It's all about how is the interaction of the engineer with his or her tools going to change by introducing agents?
Absolutely. I think it's a very powerful question. Maybe let me try to break it down into two things. So I think the terminology in itself, a workflow, can also be applied to an agentic workflow, because multi-agent systems, the way we build in Synera is also a workflow. We need the human connects the agents. So there is an agentic workflow, and this agentic workflow has tools that are also just rule-based workflows. So at the end, I think I think a term that has come to light more and more is agentic AI or agentic automation. So this is also basically a workflow where there are multiple agents working. And now when we mean a single agent, this is probably something where we don't need to program anything. We don't need to do anything. We just utilize this agent as it is given. I think a good example could be Perplexity. I think you would have heard of Perplexity. They are basically could also be called agents. It's a very powerful deep search agent. That means it has all the tools in the background, and whenever I want to search through the whole internet, I can just call Perplexity, or I can use OpenAI's deep search agent, and I can use it. So these are models that have been given predefined tools that can perform a given task. Now, what we see, or what at Synera we think about this engineering is there will always be the need for engineering tools. We always need a CAD kernel. We always need a FE kernel or simulation. We always need a costing system. And these things I don't think will change. This infrastructure is too huge to be displaced. And therefore, we need to figure out ways how to connect LLMs into this world. And that's how we see it in Synera. So probably there will still be these workflows or rule-based automation needed because we need to capture a lot of engineering expertise first into workflows. And then these workflows need to be supplied to agents who are still new to engineering. But as they keep using these tools, they will also learn from the input and output relationships. Okay, when I design rubber parts, when I use this rubber material and I use this tool, I get this output. So that means this rubber behaves in this way. And when they keep using the tools more and more, these agents will then develop their own expertise, and they will probably become a rubber expert engineer.
Yeah, I've been discussing that the last couple of days, the need for producing workflows. Now, I assume that the engineer is used to knowing, even as a student coming from university, you learn how the process works, and you find your own way in, how you start a project, how you go through the project. Maybe it's a little bit different from market to market, from car to plane to other things, technology. But nevertheless, so the engineer, I assume, has learned and come to their own way of doing things. Now, but nevertheless, maybe for other people who have not been used to now, as because of the democratization, difficult word, of AI, even people who have not been used to, have not been trained to, they are going to need tools to maybe produce these workflows. But I think my question was more on the topic of, are we still going to be calling those workflows then, or are they going to be agents? But I think you're saying maybe as long as there are still pieces that are missing, if within your company today you can choose within your engineering team 100 workflows, and in the future you can choose 100 agents, or maybe you're going to be further away from those because you're just going to talking to your central agent. You say, give me a design proposal for XYZ. Oh no, by the way, give me 10, by the way. And here's the request for proposal, etc., etc. Yeah, and on the topic of agents, agentic, yeah, I've said that a couple of times. For me, it's still all agents. I mean, the central agent sits behind my LLM and does what I need. I'm still not sure that I understand, but I'm not going to have that discussion again, because the listeners who have been here will know that I've shared that. I'm a little bit stubborn on this one, I believe, but I don't think is that important. One thing I do want to specifically ask you is, you talked about prompting, you talked about tools. Prompting, we know that's half a year ago, the $300,000 positions for prompting, which in the meantime, where people can earn a couple of $100 million being taken in by huge tech companies. It's all relatives. Nevertheless, I'm going to be ask you, what does make prompting successful within the engineering environment? The same as anywhere else, or what would you say specifically?
Absolutely. I think there is also a lot of research findings happening where people are investigating the positional encodings of prompt. So that means if you can write a prompt starting with point A, point B, point C, but if you just change it to point C, point B, point A, there are also coming differences in how these models, think. So there is a lot of research happening on a lot of different, let's say, prompt sensitivities. But in general, what we learned about prompting for engineering is there are two aspects again. We need to still describe or represent these engineering processes. So let's say we developed a engineering workflow that describes how the FEA processing of a suspension arm takes place. We need to represent this somehow to LLMs, and this we could do in multiple formats. Either we could prompt it, we could kind of encode this into a separate format, or we can just hide it from the LLM that they never see it. When we prompt it, it's quite fascinating to see how much these LLMs can understand just by a very good prompt. And by a very good prompt, it means the input and the output and what is happening actually inside the tool is well described. And this is what we see also across this software industry, that if there are softwares with good API, with good documentation, with good, let's say, in general knowledge, we can just convert this into like a RAG format and then we can use it. And the second aspect of prompting is this role prompting. So when we want an agent to behave as an injection molding expert, we can just we start by declaring this agent as you are an expert in injection molding. You think about injection molding design principles. And this prompt is going to give different outputs for different models. So this prompt, along with the tool, when we ask it to GPT-4, is going to be different than when today we ask it to Claude 4 or Sonnet 4 or something like this. But what in general makes things effective in prompting is what we write, how we write, and where we write it. So there is a really an effect of if you put the tools in the first, let's say, 500 tokens or lines, if you put the description in the next 500 tokens, or how you write it, where you write it, and yeah, what you write. So I think these three things definitely have a sensitive effect on prompts for different models.
Okay, yeah. It's along the lines of what I've been thinking, I believe, from the very beginning. It's like, as long as these systems work for us or more and more work with us, some of us are saying towards AGI, as you say, like the role model. For me, it's about talking to another engineer, right? An engineer can be the customer, can be whatever that person is. And you just say, so now I have whatever mechanical engineer sitting there the next time. So it's about, I think it's going to be, in the end, it's going to be interaction. I'm expecting my LLM to ask questions, not to just run off, because it's like, it doesn't matter if we are in official meeting together, a customer, or internally, people sitting, what does the customer want, et cetera, et cetera. It's the interaction, I believe. And I would expect that the LLM in front of the agent, the central agent, is going to be asking questions from me. So it's like, so even if I am not going to be good, I think today, yes, I believe it's still very good, important, the prompting, but I think it's going to be less important, because I believe that we're just going to be talking as, in this case, as engineers. The engineer is going to say, my customer wants XYZ, and the customer, internal, external, is going to be an engineer as well, let's say. And they're just going to start off with one sentence, and then you're going to ask, oh, what do you mean? It's going to be A or B. So I think the interaction, that's what I'm going to be expecting from an LLM, to ask whatever it is the LLM does not know, and then to go off. So, and I would almost expect the agent to take care of that and to say, okay, now I know enough. Now I can do something useful for you. And if on the way there, I have again a question, I will ask you the question. Good. So, what does it mean? What is all of this mean? Can you share a customer with us in specific areas, and if not a specific name, what are the specific markets that you're working in that specifically engineers are? Maybe we come back to the topic before that they are more interested than maybe in other market segments.
For sure. Maybe to also touch upon your last thing about human feedback, I think this is also like the one of the powerful things that happen in post training of LLMs. So there is this technique called reinforcement learning from human feedback. And when we have let's say, the right system in place to collect this human feedback, and then you can generate models that have learned from all this feedback that we give them, the way we talk to them, and the way we interact with these LLMs. And I think that's a really powerful thing that you mentioned. I agree. And now coming to your question about where we are, yeah, sure, I'm absolutely happy to share some of our customers. So, for example, NASA is one of our customers.
Oh, just a small customer as an example. A nice start. Good. Okay.
Yeah, so NASA has this vision to, they call it text to spaceship. So they want to, I think they pioneered the system engineering in the decades back. They pioneered system engineering, and now they want to also pioneer into this whole agentic world. And we work closely with them in building multi-agent systems and so on. We also have strong technology partners like Amazon, and we work with them as to develop a lot of these pilots to show that the technical feasibility works. We have been seeing a lot of traction, especially in the supplier industry, across some French suppliers, some US suppliers, and so on. So I would say we primarily operate inside this mechanical engineering software world, but I think this is changing. We have received a lot of requests from electrical designers recently. We have also chip designers. They also see some of the automation capabilities, even EV battery cell engineers. So I think we try to act as fast as we can, but today our strong suit is in structural engineering, and we see a lot of customers using us in this direction. We also have a marketplace, so we don't do this alone. Actually, we are also partners with technology partners with Siemens, with Altair, with basically every big or major engineering tool provider. So we have a marketplace, and we try to connect all tools into one place for agents. That's our really the goal.
Very good. Before we're going to come to a close on the more general, change happening by introducing agents, I had this very specific topic, which is education. Like, you recall that I shared with you specifically, with you listeners, this episode with Harish Tempe, who had just graduated from MTech from the country from Madras, where you're from yourself. It's coincidence, but there you go. So I think, like Harish, many people are moving into engineering, moving engineering to the next level. Now, what does that mean, you believe, to the future curricula at these universities? Now, when I studied, that's long, long, long time ago, it was more like the introduction of the PC, and people didn't want to use the PC and notebook, right? So that's different times. But I still believe maybe that's still kind of the same. But the topic is like, what do young people, or even older people, if they want to just start a new curriculum, what is it they still need to learn? Theory, practice as the baseline, and where is then technology going to take over? I mean, the question always is like, or do we then still need to understand the basic physics of mechanics, or can we just say the LLM to build something?
Yeah, it's a beautiful question. I mean, this is also one of the things I think for myself. And what I realized was we should always treasure our curiosity. We should always try to hone our curiosity skills. That means the getting answers is going to be much easier as future the technology grows. But asking the right questions is going to become even more difficult. And therefore, I think one of the strong ways I think about is, can I think originally, in the sense, can I think about new ideas not by, of course, I will take AI's help, but I want to first start with a blank paper and come with an idea myself originally, and then take an AI's feedback, and then I have the curiosity back to the AI. Why do you suggest this? Why should we go this way? I think curiosity also naturally comes by doing many things. So and with AI, doing many things is going to be very easy. And I think that is what I also think education will orient towards. I think everybody is going to use ChatGPT. Students will also probably use it for completing their assignments and so on. So there is, I think the education world will probably change a bit or adapt a bit to these changes. But what I realized personally was to always keep improving the curiosity skills, no matter if it's engineering, if it's life, or if it's the business aspect. Curiosity always has a special place for humans. This is my broad view on it.
I'm going to just stop here. It's a wonderful close. Treasure your curiosity. How could I say it better? Or repeat what you said that NASA is doing, text to spaceship. That's a wonderful quote as well. And I think it says it all. Ram, thank you very, very much for having taken us, having shown us, as I said, taken us by the hand, by the ear, by explaining us how you within Synera are transitioning on the top of or moving from workflows towards agents. I think it's a very, very interesting change that is happening, that is taking place there. I would almost love to go back. I would say to the drawing board. Well, that was my time where I started and moving it into the PC. But again, looking at what can be done, what is happening today, it's very impressive, and it feels to me that your company is going to play a very important role in this transition. So thank you very much for your time again, Ram.
Thank you so much, Peter. And also thanks to the listeners and all the thing that you do, Peter, to organize these podcasts. I think our community, especially this mechanical engineering field, definitely needs this kind of a podcast to stay updated and be curious. And thanks to you for taking this great initiative and doing it together with everyone in the ecosystem. And was a pleasure to have this conversation with you.
You're welcome, Ram. Thank you very much. Have a good day.
Thank you so much.